Hello friend, in previous video we discussed all details about center of gravity and centroid. In this video we discuss the method of finding out center of gravity. Before the start video, we requested to all engineering students to subscribe my channel. The method of finding out center of gravity are two types. The name of the two methods are the geometrical consideration and number 2 the method of moments. Today I discuss about the geometrical consideration, and next video we discuss the method of moment. So let's begin. In geometrical consideration, we can find the center of gravity of some plane figures by some formula. Now we see the formula of some plane figure. The name of the first figure is rectangle. Here this is a rectangle. The length of a rectangle is b and depth is d. And the CG of a rectangle is at the point where the two diagonals intersect each other. This point is denoted by G. Here this point is the position of CG of a rectangle, and x bar is the distance of CG from y axis and y bar is the distance of CG from x axis. So this distance is equal to the half of the length, and this distance is equal to the half of the d. So x bar equal to b by 2 and y bar equal to d by 2. The next figure is triangle. This is a right angular triangle. The height of the triangle is h and base is b. And suppose this point is the location of CG of this triangle. It is denoted by G. Now if x bar is the distance of CG from y axis and y bar is the distance of CG from x axis, but for a triangle the distance of CG from the base is always 1/3 of height. Now for this triangle, when A be the considered as height and B be the considered as base, then distance of CG from the base will be y bar, that equal to h by 3. And when B be the considered as height and H be the considered as base, then distance of CG from the base will be x bar, that equal to b by 3. Okay. The next figure is circle. This is a circle of radius r. The location of CG of a circle is at the center. So for a circle, x bar equal to y bar equal to r, because they are two radius of same circle. Okay. The next figure is semicircle. This is a semicircle of radius r, and x bar is the distance of CG from y axis and y bar is the distance of CG from x axis. So for a semicircle, x bar equal to the radius of the r. Okay. So x bar equal to r and y bar is the distance 4r by 3 pi from the base. Okay. The next figure is quarter circle. This is a quarter circle and this is the axis of symmetry. Okay. So the CG of this quarter circle will be lie on this axis. Suppose this point is the CG of this quarter circle. It is denoted by G, and x bar is the distance of CG from y axis and y bar is the distance of CG from x axis. So for a quarter circle, x bar equal to y bar equal to 4r by 3 pi. Okay. The next figure is trapezium. This is a trapezium and two parallel sides are A and B. The larger sides are B and small sides is A, and the distance of two parallel sides is H. Okay, and this point is location of center of gravity of this trapezium. It is denoted by G, and x bar is the distance of CG from y axis and y bar is the distance of CG from x axis. Okay, so x bar will be half of B. Okay, and y bar will be B plus 2a by B plus a into h by 3. Okay, this is the formula for trapezium. And the next figure is hemisphere. This is a hemisphere of radius r. Suppose this point is the center of gravity of this hemisphere, and x bar is the distance of CG from y axis and y bar is the distance of CG from x axis. So for a hemisphere, x bar will be equal to the radius of the hemisphere and y bar will be equal to 3r by 8. Okay, and it is remember that y bar is the distance of CG from the base. Okay, the next figure is right circular solid cone. This is a right circular solid cone of height h and radius of base is r. Okay, and x bar is the distance of CG from y axis and y bar is the distance of CG from x axis. So for a right circular solid cone, x bar will be equal to the radius of base. So x bar equal to r and y bar equal to 1/4 of height, that is h by 4. Okay, the next figure is a sphere. The CG of a sphere is at the distance of d by 2 from every point, where d is the diameter of the sphere. Okay, so the location of CG of a sphere is at the center of the sphere. So the distance of center of the sphere from the free surface of the sphere is equal to d by 2 or radius of the sphere. Okay, please like, comment and share this video and subscribe my channel. Thank you for watching.